Hey everyone, the other day we started using our textbook, and just as a reminder, we are on chapter 2 and we're focusing on lesson 2-8. So we will be on pages 187, basically, which we've already done, 188, 189, so this one right here you're seeing is 187. So I'm just going to really quickly refer back to my notes, and then I'll show you where we are in the book. But make sure you have your textbook available if your parent picked that up for you earlier in the year. Okay, otherwise remember that it is this icon right here in your apps page. Okay, so just as a reminder, we talked about something called a constant rate of change. So, and that just has to do with how your points are changing, how your x values change, and how your y values change, okay? And then we talked about delta y over delta x. Delta is the little triangle, it's just a Greek symbol, and it means change, okay? So these are all the same. Delta y is change in y over change in x. So notice that even though y is down, it goes up, and even though x is up, it goes down. Okay? So let's look at, I believe this is on page 188. So I'm just going to double check. At the bottom, yes. So just as a reminder, if something has a constant rate of change, it's going to form a straight line, okay? So it's going to be what we call linear, okay? And obviously, it kind of starts off like that, AR. And that word is linear, it means this is straight, okay? So it says, use the graph to determine the constant rate of change in miles per hour while driving. So I know it's kind of hard to see my numbers on here. So if you're looking at your book, we might be able to see this a little better. So actually, let me just refer to this because we can see this. Okay. So a reminder that constant rate of change is delta y over delta x. I'm going to write that down. Okay, and whenever we're doing that on a graph, we often say rise over run. Rise meaning going up or down, so maybe rise or fall, and then run meaning we're going left and right, okay? So if I was to put these points in a table, so I'm going to go back to this other picture, and I'm going to put 130 and 260, okay? So y'all are going to actually see me do it two different ways. So over here, I put the points, okay? So if these were in a vertical table, which some of you have seen, 130, 260. One thing I can tell is this will have a constant rate of change, again, because it's linear. So how much is it from 30 to 60? And it's a change of 30. 30 plus 30 is 60, okay? And then how much is it from 1 to 2? Well, that's plus 1. Okay, so the delta y, that's this. This is our first time with a vertical table, is 30 over delta x, which is 1. Now, if I'm doing this on a graph, I'm just going to count up and over. So I would count from right here, which I know it's hard to tell, but that's at point 30. It's telling me that 1 comma 31 over 30 up and over. Okay, so I'm going to go back to where I can see it. Okay, so this distance, if you can tell, from here to here, so if you think about this, one section is 20, 40, 60, 80, 20, plus another 20 is 40, plus another 20 is 60. Each section is 20. Okay, so I have a whole section and I have half of a section. And I know it's half of a section because I can look right here. So this distance is 30. And in order to know that, you really have to be able to read the axis. Okay? And then going across, notice that we start here at 1, and I go to here. It looks like we're going over 2, and we are going over 2 sections, but notice that these are split in half. So I go from 1 to 2. So this section is actually equaled to 1. 2, take away 1, is 1. Okay? So I know it's a little confusing at the beginning. Trust me, I understand. Okay? So again, what we see here is the rise is 30 and the run is 1. And officially that's for the next one too. There's a whole section, that's 20. There's a half a section, that's 10. So 20 plus 10, 30. And then here to here, 3, take away 2 is 1. This distance is 1. So it's 30 over 1 each time. Okay, so it's rise over run. Okay? So now let's look at the next problem. And we don't have to write this out, but we'll just talk about it. It says, on the lines below, explain what the points represent. So basically, it doesn't give me a title, so I hate that, because as a math teacher, we need a title for this. But it looks like it's time and distance. So 0, 0, what does that mean? Well, that means when I have traveled for 0 hours, I have gone 0 miles, right? And as soon as I have traveled for 1 hour, I have traveled 30 miles. So that's what that means. 1 hour, I've gone 30 miles. Okay? So now let's look at page 190. Let me see. Make sure I have the right ones here. Actually, we're going to go to the next page. Okay? So, we are going to be determining the constant rate of change. And this is again on page 191 in the book. So, remember constant rate of change, and we just want to make sure we simplify it. Delta y over delta x, okay? And here's a line here so that we can make sure we don't mix these two up. So, delta y, this is x, this is y. Delta is change. How much does it change from here to here? From here to here, and from here to here. How much is it increasing each time? Looks to me like it's going up 6. So each time I'm putting plus 6 because that is how much it changes by. And the plus is just a good indicator for me that I know it's going up. Okay, now for my times over here. 1. Plus 1. So 1 plus 1, 2. 2 plus 1, 3. Plus 1, 4. So 6 over 1. So that is my constant rate of change. And that's it. This will not simplify. You can put 6, but right now let's go on and keep it as 6 over 1. Okay? So one thing we know, since this has a constant rate of change, if I was to graph this, it would be linear, okay? Now the next thing I just want to check to see is if it's proportional, okay? Because before we talked about if it has a constant rate of change and goes through 0, 0, then we call it proportional, okay? So I'm going to take my table backwards. 4, 3, 2, 1, right? Because each time I go back 1, 24 minus 6 is 18, 18 minus 6 is 12, 12 minus 6 is 6, 6 minus 6, 0. So guys, this already has a constant rate of change and it's going through 0, 0. So what I know is it is proportional. It is a straight line that goes through 0, 0. That's what we are talking about when we say a proportional situation. Constant rate of change, and it goes through 0, 0, also called the origin. Okay, so now, let's see if we can figure out how much it goes between each of these. So I'm going to be quiet for a minute, and I want you to subtract to figure out 36 minus 18 gives me what? Do that. And once you do that, you can do 54 minus 36 and see what you get. Okay, so 36 minus 18 is 18. So 18 plus 18 is 36. 54 minus 36 is 18. It went up 18. And again, this one went up. 72 minus 54 is 18. Okay? So my delta y, my change in y is 18, or a positive 18. Delta x, let's see. So these are easier, right? 4 minus 2, 6 minus 4, 8 minus 6. So each of these increases by 2, right? 2 plus 2, 4. 4 plus 2, 6, right? So our delta y over delta x is 18 over 2, which, when I simplify, becomes 9 over 1, right? So that's my constant rate of change, 9 over 1. Okay, now just to double check, let's see if it's proportional. So remember, we take the table back to see if it goes through 0, 0. Well, each one of these is changing by 18, right? So when I subtract 18, 18 minus 18, I get 0. And each one of these is changing by 2. When I subtract 2, I get 0. So this one is also proportional. So it's also a straight line that goes through 0, 0. Okay, so we're going to run out of time here. But let's try one more. Delta y over delta x. How much are those changing by? And by the way, this is not in the book. I just made this up. So you can pause this and write out the table if you want. Hopefully you can tell that it changes in the y, delta y, by 5. And remember, it's reversed. So even though it's down, it goes up. And this changes by plus 2, right, each time? So that, and this is fine. You can't simplify this. Yes, it's improper. I could divide it, but actually, we want to leave it like this. Remember, we talked about that rise over run? We want to leave it like that, okay? So so here's my constant rate of change, but is it proportional? Does it go through 0, 0? And I can tell right away it doesn't. This goes through 0, 1. So this one's not proportional. Okay, so you're going to try these two by yourself.